today we're going to tour the solar system. But first of all, I just wanted to show you this picture. Now, what do you think this is? Do you think this is a photograph of something real? And if so, where is it? Or do you think maybe it was something just created using Photoshop, just like a fake picture? What do you think? So you can ponder on that and we'll come back to it at the end of the session. So this is what we're going to do today. I'm going to use a software called Celestia to show you the solar system. It's actually a free software. You can download it yourself and try out just what I'm going to show you. But we're going to start off looking at the Earth and then its the relationship to the Moon and the Sun. Then we're going to look at the orbits of the planets, so the way the planets orbit around the Sun. Then we'll go and tour each of the planets in turn to look at some of their characteristics, and we'll learn about some of the moons. And then at the end, we'll learn a bit about the range of distances in the solar system. Now, while I'm going through, there's a few other questions you can think about. So, do all planets have moons? Do all planets have rings? Which planets have liquid water? And then here's the exciting one. Do you think there's life anywhere else in the solar system? So, let's tour the solar system.
Okay, so here's Celestia, and when you first go to Celestia, it shows you Earth, our wonderful planet. So you can see the blue of the oceans and the green and brown of the land and the white of the clouds. And Celestia has all sorts of controls. One of them is that I can actually turn the clouds on and off like that. And I can also move around. So with Celestia, it's as though you're in a spaceship and you've flown up into space thousands of kilometers and you're looking down on the Earth. So I can also move around so that I can see different parts of the Earth. You can see right now we're looking at Africa. If I can go up or down, then I can see the ice caps. And obviously right now it's daytime in Africa, but if I move around, I go to the other part of the world where it's nighttime. You can see that it's in darkness because it's not facing the sun. So it's nighttime for Australia there, and for part of the United States, but for us it's daytime. Now another cool thing I can do in Celestia is I can speed up time so that you can actually see the Earth rotating. So let's speed it up, and here we go. You can see the Earth rotating on its axis. So let me just zoom out a bit. In other words, I'm going to make the Earth smaller and see what else we can see. Again, let me speed up time a bit more. Can you spot something? Something moving? I'll turn on some labels, and yes, that's our moon orbiting the Earth. Now to show its orbit, I can turn on the orbit lines, and let me just move this around a bit, and I'll just zoom out a little bit more. Okay, and now you can see the moon orbiting the Earth. Don't worry about that red line, that's the orbit of the Earth around the sun. So there's our moon orbiting the Earth. And I can also go and take a look at the moon and slow things down. I just click on it and then I can go there, and here's our moon. Now if I move around, you'll see that there are lots of craters on the surface, those round features which show where there have been impacts, where objects have come and hit the surface of the moon and created these impact craters, and they're all over, or over a lot of the surface of the moon. Now the moon doesn't have an atmosphere, and that means it doesn't have any weather, so there's no wind or rain to wash those craters away. So that's why they're still there, even though they happened thousands and some of them even millions of years ago. Now, we also have impact craters on Earth, but many of them have been eroded by the weather or by tectonic activity. So we have the Moon orbiting the Earth, but we know that the Earth also orbits the Sun. So let's go and have a look at the Sun. Here's our Sun. I hope you remember from last time that the Sun is a star. And you might be wondering, what are those dark spots that you can see? They're actually called sunspots, and they are areas that are slightly cooler than the rest of the surface. So the surface of the Sun is about 5,500 to 6,000 degrees. That's degrees Celsius. But those dark areas are about 1,000 degrees cooler. So they're still pretty hot. They're about 4,500 or 5,000 degrees. But because they're cooler, they look darker. Now, did you know that the Sun also rotates? So if I speed up time, you can tell that it's rotating by the sunspots moving. And in fact, it was Galileo who first noticed this. He made drawings of the sunspots and noticed that they were moving as the days went by, and eventually realized that the Sun was rotating. Now, once again, I'll zoom out, and you might be able to see some little dots moving. I hope you can work out what those are. Yes, they're the planets. So once again, I'll put on the orbit lines. Let me just rearrange things. So there we go. So now we can see the planets orbiting the Sun. And these are just the inner planets at the moment. Now, I want you to think about three things. First of all, what is the shape of the orbit? What direction are the planets orbiting in? And do you notice anything about the speed of the different planets? I can actually speed things up a little bit, might make it a bit more obvious. So you should be able to see that, first of all, the orbits are not quite circular. They're actually slightly elliptical, like an oval shape. They're almost circular, but not quite. All the planets are going in the same direction. That's anti-clockwise, the way we're looking at it. And you should also be able to work out that the closer the planet is to the Sun, the faster it goes. So you can see that Mercury is going faster than Venus, Venus is going faster than Earth, and Earth is going faster than Mars.
So right now we're looking at the inner solar system. Let's now take a look at the outer solar system. And to do that, I have to be able to zoom out. You can see I have to go a long way before we start seeing the outer planets. Here comes Jupiter, Saturn, Uranus, and finally Neptune. So you can see from this that the outer planets are much, much further away than the inner planets. Now we can hardly see the inner planets at all. Now, just as before though, let me speed up time so you can see the planets moving. We still have the same characteristics. The planets are going in the same direction around the Sun. Their orbits are elliptical, and just as before, the planets that are closer to the Sun go faster than the ones that are further away. If I speed up even more, it looks a bit funny, but let me speed it up. You can see that definitely Jupiter is going faster than Saturn, Saturn faster than Uranus, and Uranus faster than Neptune. Let me slow down again. So now let's go and look at each of the planets in turn. So first we're going to go to Mercury. So Mercury is the smallest planet in the solar system. Let me just turn off those lines. And it's the closest to the Sun. And you can see that its surface is filled with craters, a bit like our Moon. So it's a rocky planet with lots of craters. And because it's closest to the Sun, you might think that Mercury should be the hottest planet in the solar system, but actually it's not. Venus is the hottest planet. So let's go to Venus and find out why. So here we are at Venus, and what you're seeing are the clouds that are covering Venus, and these clouds are very reflective, and that's why Venus is the brightest planet in the night sky. Often it's known as the morning star or the evening star, even though of course it's a planet and not a star. But do you remember that in Celestia I can turn the clouds off? So if I do that, now you're looking at the surface features of Venus. And if you remember in the last session we also showed an image like this. So Venus is named after the Roman goddess of love, but well, it really isn't a lovely place at all. So those clouds that you can see are actually full of carbon dioxide. So if you were there, you wouldn't be able to breathe. And they also have sulfuric acid in them, so it rains acid on Venus. And it's that carbon dioxide in the atmosphere which traps the heat and makes Venus the hottest planet in the solar system. Now, apart from those clouds that will suffocate you and the acid rain that will burn you, the surface temperature on Venus is over 400 degrees. Actually, it would melt lead. So once again, if you were there, you'd just be roasted. And the atmosphere, the atmospheric pressure is about 90 times what it is on the Earth. So you'd just be crushed. So Venus really isn't a pleasant place to visit at all. Now I'm just going to turn the clouds off again to show you one thing. I'm going to speed up time so you can see Venus rotating. Now, I don't know if you remember, when we saw the Earth rotating, it was actually rotating in the other direction. So Venus rotates on its axis in the opposite direction to the Earth. In fact, in the opposite direction to all the other planets. So Venus is quite unusual in that regard. So let's leave Venus and continue on through the solar system. We've seen Earth already, so let's go to Mars. So here's Mars. I'm sure you know that Mars's nickname is the red planet, because as you can see it's a kind of reddish colour, and that's caused by the iron oxide which is in the soil or the dust on the surface. Iron oxide is basically just rust, so that gives it reddish brown colour. Now Mars has some very interesting features. I've just slowed down the time so we can have a look. You can see there is this huge gash here, which is an enormous canyon called Valles Marineris, and it's actually about 5,000 kilometres long. That's like the distance from Accra all the way to Cape Town in South Africa, so it's absolutely enormous. And then let's rotate around a little bit more. You can see some volcanoes here, and just coming up is another volcano. So this volcano here is called Olympus Mons, and it's the biggest volcano in the entire solar system, and it's about 3 times the size of Mount Everest on Earth. Now let's zoom out a bit and you'll see that, if I speed up time, see those dots moving around Mars? Those are its moons. Let me change the view. So Mars has 2 moons orbiting around it. They're called Phobos and Deimos. I know the labels might not be very clear, don't worry too much about that. They're actually very small and quite close to the planet. Let me go and have a look at one of them. Let's go and look at Phobos. You'll see it's a rather strange shape. It's not really spherical. I'll turn off those lines. And it's actually thought that these 2 moons are more likely to be asteroids that came close to Mars and then got caught by its gravity. So let's leave Mars and continue on our way. So now here we are at Jupiter, and Jupiter is the largest planet in the solar system, and it's a gas giant. It's actually made mainly of hydrogen and helium, and that means that if you were able to go to Jupiter, there would be no surface for you to stand on. You would just sink down through the atmosphere, and then eventually the pressure would get so great that the hydrogen turns into a liquid. So it's believed that Jupiter has a huge ocean of liquid hydrogen beneath its atmosphere. Now these wonderful coloured bands you can see are bands of swirling gases with different elements like sulfur and phosphorus and ammonia. Now let's let Jupiter rotate, and I want to show you one particular feature. As it goes round, we'll be able to see it. You may have heard of this. Let me stop time again. So this here is called the Great Red Spot of Jupiter, and basically it's a huge storm of swirling winds, but it's so enormous it could fit 2 Earths inside. And this storm has been seen for hundreds of years, basically ever since people could use telescopes and point them at Jupiter. The Great Red Spot has been visible. Now let's zoom out so we can see Jupiter's moons. Jupiter has plenty of moons. Okay, here we are. Now, apart from the innermost moon here, the other 4, which are called Io, Europa, Ganymede and Callisto, are the 4 largest moons of Jupiter. Jupiter has over 70 moons, but these are the 4 largest. And they're sometimes also called the Galilean moons because it was Galileo who first spotted them when he looked at Jupiter through his telescope. Now we're going to go and have a look at Io, because Io is a very interesting place. Here we go. So this is Io. Now all those strange colours are because of different chemicals that have been spewed out during volcanic eruption. So Io is the most volcanically active object in the whole solar system, and that's what gives it these amazing colours. Some people say it looks like a pizza. But now let's go on to the next planet. Do you remember which one that is? Yes, now we're going to Saturn. Amazing Saturn with its incredible rings. So the rings, although sometimes it looks like they're solid, the rings are actually hundreds of mini ringlets all next to each other. And the rings themselves are made of millions of pieces of rock and ice and dust. And they're quite reflective, and that's why the rings are very easy to see. Saturn is also a gas giant, and it also has plenty of moons. So let's zoom out so we can see the moons. Okay, now there's one particular moon I want to see. Let me just rearrange this a bit. So down here is a moon called Titan, and that's Saturn's largest moon. Let's go and have a look. Now Titan is the only moon in the solar system that has a dense atmosphere. And in 2005, a spacecraft called Cassini that had been orbiting Saturn dropped a probe onto the surface of Titan. And this is at the furthest that a human-made probe has landed. And as it went down onto the surface of Titan, it sent back amazing pictures. And we now know that Titan has its own lakes and seas and rivers. But amazingly, they're not filled with liquid water, but liquid hydrocarbons, things like methane and ethane. So Titan is a really fascinating place. But let's go on now to the next planet, which is Uranus. So here's Uranus, one of the ice giants, made of things like methane and ammonia, which gives it the bluish colour. Uranus also has its moons. One interesting thing about Uranus, which unfortunately we can't really see in Celestia, is that as it rotates, it actually rotates more or less sideways. It's tilted over so far that it's actually on its side. So Uranus is sometimes called the sideways planet. Let's go on now to the last planet in the solar system, which is Neptune. Again, Neptune gets its blue colour from elements like methane and ammonia. Neptune is also known as the windiest planet. It has incredibly fast winds of up to about 2,000 kilometres an hour rushing over its surface. Let's have a look at Neptune's moons. Let me just change the orientation, sorry. Okay. Now, I want to zoom out, so that we can see Neptune's largest moon, which is the one here called Triton. Now, if I speed up time, you should be able to notice something a little bit strange, which is that Triton is moving in the opposite direction to the other moons. And it's thought that this might be because sometime in the past maybe there was a collision with Triton and that kind of knocked it off course and sent it in the opposite direction. So we've reached the end of the solar system, and that's the end of our tour. Now that you've been on a tour of the solar system, you should realise that when you see pictures like this, which are very common, you realise that the distances are not to scale, they're not accurate. In fact, the distances are more like this. Here's an actual scale picture of the solar system. So there's the Sun over on the left, and see how close the inner planets, Mercury, Venus, Earth and Mars, are to the Sun compared to the outer planets. Now the AU that you can see on the scale there stands for astronomical unit. 1 astronomical unit is the distance between the Earth and the Sun. So you can see that Saturn is 10 AU away. That means it's 10 times further from the Sun than the Earth is. And Neptune is 30 times further. So when you see this, it's not at all surprising that there have been so few missions to the outer planets. There's only been 1 mission to Pluto, whereas there have been dozens of missions to Mars because it's so much closer. It also makes more sense that those outer planets are much colder and icy compared to the inner planets. So let's look back. What have we learned today? So you saw that the 8 planets of the solar system travel round the Sun in elliptical orbits. They look almost circular, but they are actually elliptical. All the planets travel in the same direction around the Sun. And the closer the planet is to the Sun, the faster the speed. Now, what about those other questions I asked? So, do all planets have moons? Let's take a look. So, first of all, Mercury. No moons for Mercury. What about Venus? Again, no moons. Now, I'm sure you all know the answer to Earth. Yes, we have one moon. What about Mars? Yes, remember we saw the two small moons of Mars. Jupiter, 79 moons. That's pretty impressive. What about Saturn? 82 moons. In fact, Saturn just recently overtook Jupiter as having the most number of moons in the solar system, because new moons are occasionally discovered, and that's what's happened recently. Uranus, 27 moons, and Neptune, 14 moons. So the next question, do all planets have rings? Now, I know we all know that Saturn has those amazing rings, but what about any other planets? Well, surprisingly, yes, all the outer planets have rings. Now, I wasn't able to show you them in Celestia, they're not included there, but they do all have rings. So here are the rings of Uranus, Neptune, and Jupiter. Now, these rings are much thinner and much less extensive than Saturn's rings, and much harder to see. So that's why it wasn't until spacecraft could fly out through the solar system that we could see these images. But yes, all the outer planets have rings. Which planets have liquid water? Well, I'm sure you would have got this one right. Of course, our Earth has a lot of water over its surface. What about any other planets? Well, maybe surprisingly, Mars has liquid water, but it's underground. So some underground lakes were discovered using radar a few years ago, and then they were confirmed just recently in September 2020. So Mars has underground liquid water. But some of the moons in the solar system have liquid water as well. This is a moon called Enceladus. It's a moon of Saturn, and when a spacecraft flew past it, they discovered these plumes of material squirting up into space, and it was discovered that they were water and some chemicals squirting up through a kind of crack in the surface. But also 3 of the moons of Jupiter, Europa, Ganymede and Callisto, they also are believed to have liquid oceans below a thick crust of ice. Remember that Saturn and Jupiter are far out in the solar system, so the moons are mainly covered in ice, but they're believed to have oceans underneath. Now, what about this question? What do you think? Do you think there could be life somewhere else in the solar system apart from on Earth? If so, what do you think it would look like? Now, the reason scientists are always interested in water is because on Earth, all life needs water. So if we're looking for life somewhere else, scientists believe we need to look for the water first. But let's have a look. If you go to the movies, you might think that life on another planet could look like this. These are all pictures from movies and television programs of what people think alien life might look like. But remember, these are all fiction, they're just made up. So far, we haven't found any evidence of life anywhere else in the solar system, or even in the universe. But who knows, maybe we'll find it one day. And what you have to remember is that when we say life, it doesn't have to look like us. Think of the incredible diversity of life here on our planet. All the different plants and trees and animals, fungi, fish, birds, and humans. There's such a huge diversity of life on our Earth, so maybe if we do find life somewhere else, it could be very different to us. It could even be just microbes. Who knows? So let's go back to that picture I showed you at the beginning. What did you decide? Is this a real photo or just something made up? Yes, it's a real photograph taken on the surface of planet Mars. This is showing a robotic rover called Curiosity, which right now is on the surface of Mars, travelling around, taking photographs and also taking samples of some of the Martian soil to see if we can find out more about the planet and what it might have been like in the past, and whether it might have been a place where life could have been in the past. So that's all for today. Remember, if you want to learn more, there's lots of resources online, including the NASA Solar System Exploration website. You'll find all sorts of videos and pictures and information there. So thank you for watching this session, and see you next time.